All right, good morning. Let's go ahead and take a look at that Chapter 3 review. See kind of how this goes. I'm feeling a little under the weather, but let's hopefully that I can get through this. See what we got here. So, taking off from the very, very beginning, doing just a little bit of implicit differentiation. I got my focus thing sitting on there because the camera was a little out of focus this morning. But I started taking the derivative here. So the derivative of 2x squared, of course, is 4x. And I'm taking this one with respect to x. So I'm not going to have to do the dx thing. So I've got it in chunks that the derivative of 2x squared is 4x. The derivative of y, of course, is dy dx. Now, this is the one place where sometimes people get into a little bit of trouble. You want to think about this as 2 times something squared. And so when you take the derivative, you go ahead and take the 2 times that, which would be 4y to the first, but then chain rule says multiply that by the derivative of what's inside, of course, dy dx, and the derivative of 36 is no big deal. That would be 0. Now, what I notice right away is that I've got 2 different terms here that involve dy dx. So if I were to factor that dy dx out, let me grab my whiteout kit here. If I take that dy dx out and put a parentheses right here, I would have one of those dy dx's here and 4y of them here. And I think I'll move this 4x to the other side, which leaves me with dy dx being negative 4x over 1 plus 4y. And that kind of ends my first story. Now, I'm not going to do that in this particular question, but keep in mind if I was asking, say, for example, where is there a horizontal tangent, then I would take the numerator and I would set it to 0. And that's not trivial because if x is 0, I'd have to go back into here and figure out if x is 0, then what would y have to be to make that true? And similarly, if I wanted to find out where there was a vertical tangent, I would set the denominator to 0, so where 4y equals negative 1 or y is negative a quarter, and I would plug that back into here and here to find out what x value would go along with that. But here we go. So what is the slope of the tangent line at negative 2, negative 4? So I just need to simply evaluate that at negative 2, negative 4. So we're going to do dy dx evaluated at the coordinate negative 2, negative 4. And that's going to give me 8 on top, because negative 4 times negative 2 over 1 minus 16, or negative 8/15. And we're done with the first question entirely. So second question is, where find the coordinate on the curve where the tangent lines have horizontal slopes, which is kind of what I was just discussing a moment ago. So we would start with our first piece, 3x squared. Of course, this one is the 3y squared with the dy dx attached to it. Now, we're getting into a little bit of dicey territory here because this is a product, and so we're going to do f prime g plus g prime f, as we keep kind of saying. So I'm thinking of this portion right here, the negative 6x, as f, and I'm thinking of the y as g. So f prime g plus g prime f, and of course the derivative of 0 is of course 0. Now, again, just like before, I have 2 different terms that have a dy dx in it, right there and there. So dy dx is being applied to both the 3y squared as well as the negative 6x from this term over here. And I'm going to clear these things to the other side and have positive 6y minus 3x squared. So it looks like then dy dx would be 6y take away 3x squared all over 3y squared minus 6x. Now, I probably think it would be intelligent to go ahead and do one last little thing, which is divide all of these pieces in here by the number 3. Because we can always make things a little bit smaller. Now, unfortunately, this question didn't end at this moment because it says, where are the tangents horizontal? And so what I need to do is I need to find out where this numerator here is equal to 0. So I would have 2y minus x squared is 0, which means that 2y is the same as x squared. which of course would tell you that y is x squared over 2. So what I need to do now is I need to go back into the original problem and substitute that back in order to figure out what's going on. So I'm going to take the original problem, x cubed plus y cubed, but of course y is x squared over 2, minus 6xy, but of course y is x squared over 2 again, and I want to know where is that equal to 0. Now that's not a particularly simple thing to find, and I don't have a ton of room in here. So let's see, I'm going to have x cubed here, plus x to the 6th over 8, careful because the 2 is also being cubed, and then over here I'd have minus 3x cubed. Now, in this particular story, I'm not a big, huge fan of this 8 sitting right here. So first thing I'm going to do is simplify this down to x to the 6th over 8 minus 2x cubed, kind of a little combination of like terms. Let's multiply by 8. And then I notice that these both have an x cubed in common. Like I said, this problem is a little bit on the lengthy side. So we're pretty well ready to go now, because the only way that this product can be 0 is if x itself is 0, or if x itself is the cube root of 16. Now, the last little piece, though, is I wanted to know the coordinates. Now, keep in mind a coordinate just doesn't have x, but it also has a y. So if I go back and I look right here, I know that y is half of x squared, so half of 0 squared is still 0. But this one is a little bit obnoxious, but I have to take half of this thing and then square it. So that would be the cube root of 16 squared over 2. And those would be my two, one fairly nice component, one pretty ugly component. And of course, this is one of those that we referred to before as a Folium of Descartes, and we could actually look at those and see if in fact we were successful. It's not a terrible idea to go into Desmos and take a look and see if what we have just said actually makes sense. So I'm pulling up a quick Desmos window, and let's go ahead and see what we get in that thing. So let's go back over here and let's go ahead and share that screen real quick. And what I've got is x cubed. Oops, I guess it wasn't typing, was it? I've got an x cubed, plus I've got a y cubed. And then we have a minus 6xy is 0. And we have this kind of loop-de-loop. And I think you can see right here at 0, 0, the coordinate 0, 0. We definitely have a place right here where the tangent was not only horizontal, but also vertical, depending on what portion of the loop we are on. The other part is a little harder to do. And so it was the cube root of 16. And then comma, this is the part that's going to be a little bit harder to do. It's going to be 16 to the 2/3 power, and then of course divided by 2. And that should be the other place right up here where you can see that the tangent does look like it would be horizontal. All right, so let's get back to where we were in our problems. So taking back off on problem number 3, and that'll be the last one for this video. We have yet another little situation of a product rule. However, this product rule also has a little chain mixed in. So we're going to call F just the x piece, and we're going to call G the e to the sine x piece. So H prime is going to be f prime g. Let's see, f prime g would be 1 times e to the sine x plus g prime f. So the g prime f, the g prime is the tough part. So remember, the derivative of e to the u is e to the u du. And I didn't give myself enough space, so let me go ahead and fix that a little bit. And my du part is going to be the derivative of sine, which of course is cosine. Now, a fairly typical thing to do in problems like this, it's not mandated, but it's usually smarter, is if you have a problem, especially with exponentials, we tend to have a repeated piece. So if we were to factor an e to the sine x out, we'd have a 1 on this piece, and we'd have an x cosine x over here. And that's a little nicer looking thing, especially if you are going to maybe find where that's equal to 0 or where it's undefined. And then part B is very clearly just a simple chain rule. Don't forget that the derivative of a tangent is a secant squared. So h prime is going to be 3 secant squareds of 5x. But now we need to multiply that by the derivative of the part inside, which the derivative of 5x is just 5. So we're looking at 15 secant squareds of 5x. And that's going to end the first 3 questions on the video. And I'll be back for the next one. Bye-bye.